This video, we're going to talk about Descartes' rule of signs and the rational zero theorem, or I call it the rational root theorem. Both of them are techniques to help us with factoring polynomials of higher degree. So let's start off with f of x is equal to x to the fourth plus 15x squared minus 16. I'm going to make a chart here. Plus, minus, and C stands for complex. The number of sign changes in f of x is going to go into my plus column. So I start off positive and stay positive. That's not a sign change. Positive to negative, that's one sign change. Then I'm going to find f of negative x. And that's going to be a negative x raised to the fourth is still going to be an x to the fourth. And negative x squared is still going to be an x squared. So the number of sign changes in f of negative x is what starts off in my negative column here. And I need my rows to always add up to give me my degree. So since I only have 2 right now, there needs to be an even number always in column C. And there is 2 plus 1 gives me a degree of 4. I cannot take pairs out of my positive column or my negative column to put them in my complex column. So this is my only option. I'm going to have exactly one positive answer, maybe rational, maybe not rational, but definitely real. I'm going to have one negative number, possibly rational, but maybe not rational, but definitely real. And I'm definitely going to have 2 complex answers to this. So now I'm going to use my rational root theorem to try and find my possible rational zeros, which I'm going to abbreviate P, R, Z's. They're my possible rational zeros. They're going to be made up from plus or minus the factors of the constant. Ignore the sign because I got plus or minus out here. And the factors of the leading coefficient down here. So my PRZs are going to be plus or minus. Factors of 16 are 1 and 16, 2 and 8, and 4 and 4. And the only factors of 1 are 1. So our PRZs are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, plus or minus 16. There's only going to be one answer that works for the positives. So I'm going to start on the low end and work towards the high end. I'm going to start with a positive 1 and test it first. Remember to put your zeros in for your missing terms. Now, if you want to test these with your calculator, to see which ones are going to work so you don't do a bunch of scratch work for numbers that aren't going to work. Usually your teachers let you do that, but you might get a no calculator part of the test here. There we go, that one worked, right? And so this is going to be x minus 1 times x to the third plus x squared plus 16x plus 16. And I want to go ahead and factor this completely. X minus 1 times x squared times x plus 1 plus 16 times x plus 1 is going to give me x minus 1, x plus 1, x squared plus 16. If I did not recognize that I could factor that by grouping, I could have gone and I would have stopped with my positives because I already found my one positive answer. I would have tried -1 from my negative list on this piece right here. So let me go ahead and show you that as an alternative here. It's a negative 16. That's 0. And that would have given me factors of x minus 1, x plus 1, and x squared plus 16. It works out both ways, whether I factor by grouping there or whether I continue to use the zeros from the rational root theorem. But if you recognize that you can factor by grouping with the cubic, you can stop. Otherwise, we want to get it down to where it's quadratic. We see that this is an irreducible quadratic that's going to give us the two complex answers that we have there. If this is factorable, continue to factor it from there using regular factoring techniques. All right, let's try number 19 here. X to the third plus 2x squared minus 9x minus 18. I really don't need Descartes' rule of signs or the rational root theorem here, but I'm going to do it because that's the way the teacher told me to do it. Number of sign changes in the original is 1. Number of sign changes in negative f of x, all the things with the odd degrees of x are going to change sign. All the things with the even degrees of x are going to keep their sign. Negative to positive is 1. Positive to negative is 2. Leaves me with 0. And I have a 1, 0, 2 as an option. This tells me I'm guaranteed exactly one positive answer, but I'm not guaranteed any negative answers because there could be two complex answers. So when I find my answers with the rational root theorem, factors of 18, 1 and 18, 2 and 9, 3 and 6 over 1. So this is plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, plus or minus 18. One is not going to work this time. Two is not going to work. Three is going to work, I believe. Let's check it out. Okay. And then if I want to take it further from there, I found my one positive answer. I'm going to have to try and get a negative answer or two. But since this is quadratic, let's just go ahead and write this as, and I can see that I can factor it further from there into, and it's completely factored. Now let's try f of x equal to 3x to the third. That's 14x squared plus 3x plus 20. Descartes' rule of signs. 1, 2 sign changes. One sign change. 0 or 0, 1, 2. So I'm guaranteed a negative, but I'm not guaranteed a positive. So I'm not going to start with the positives. I'm going to start with the negatives here. Factors of 20. Like so. Over 1 or 3. Those are the factors of 3 there. So I'm going to have plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, plus or minus 20, plus or minus 1/3, plus or minus 2/3, plus or minus 4/3, plus or minus 5/3, plus or minus 10/3, plus or minus 20/3. Lots of options there, right? Let's hope that we get to an answer rather quickly here. Let's try -1. 3, -14, 3, 20. That's a -3, -17, 17, 20, -20, and 0. That makes this an x plus 1 times a 3x squared minus 17x plus 20. Do we have anything more that's going to factor that 3x squared minus 17x plus 20? Let's see. Factors of 60. They're going to add to be -17. -1, no. 60, -2, and -30, -3 and -20, -4 and -15, -5 and -12. There it is. So x plus 1 times 3x squared minus 5x minus 12x plus 20, group and group. X plus 1 times x times 3x minus 5 minus 4 times 3x minus 5, x plus 1 times 3x minus 5, x minus 4. So my zeros that would have worked here are -1, +4, and +5/3. Let's move on to number 21. F of x is equal to 3x to the third minus 4x squared plus 9x minus 12. I'm just going to show you how to do this one by grouping. I will go and do Descartes' rule of signs. This is x squared times 3x minus 4 plus 3 times 3x minus 4. It's going to be a 3x minus 4 times an x squared plus 3. So my only answer that's going to work here is going to be x equals 4/3. This is going to be an irreducible quadratic, so this is completely factored. So when I do Descartes' rule of signs, this is just what my answer is going to be there. But let's do it the other way that the teacher instructed us. So sign change, sign change, sign change. That's 3 sign changes. This is a -3x cubed minus 4x squared minus a 9x minus 12. There's 0 sign changes there, so there's no negatives. We also have 1, 0, 2 as an option. This is actually the option that I have because I have 2 complex answers that I can see there from the sum of squares there. And so I'm going to have at least 1 positive answer. These are going to be factors of 12. Over factors of 3, which which is plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12, plus or minus 1/3, plus or minus 2/3. 3/3 is 1, plus or minus 4/3. 6/3 is 2, 12/3 is 4. I don't need to list those again. And it is going to be positive 4/3 that I know is going to work from my other technique that I did before. 3, -4, 9, -12. You may also get that from your calculator if you know how to do that. 3 goes into 3 one time. 1 times 4 is 4. Gives me a 0. 0 times anything is 0. Bring down the 9. 3 goes into 9 3 times. 3 times 4 is 12. The 0. And that gives me factors of x minus 4/3. 3x squared plus 9. I'm going to pull the 3 out. I'm going to put that 3 in here to get rid of this fraction. Like so. You see the whole problem from beginning to end. You see that we get the same answer whether we factor that one by grouping or we use Descartes' rule of signs and the rational root theorem. That was number 21. Let's move on to number 22. So Descartes' rule of signs tells us to look at sign changes in the original. 1, 2, 3, 4 sign changes in my original. That should lead me to believe that there's going to be no sign changes in f of -x. And there's not. So this can be 2, 0, 2. It could also be 0, 0, 4. In this class, you're not going to get a situation that I know of unless you can find it easily with a basic factoring technique where all of your answers are going to be complex like this. So right now, let's just kind of forget that that option is an option. And we're probably going to have 2 or 4 positive answers. So let's look at factors of 9, 1, 3, or 9. Factors of 2 are 1 or 2. So that's going to be plus or minus 1, plus or minus 3, plus or minus 9, plus or minus 1/2, plus or minus 3/2, plus or minus 9/2. Let me go ahead and just try some things here. This is just going to be trial and error for me. Let's try 1, 2, -5, 9, -15, and 9. I'm not going to try any of my negative answers because none of them are going to work. So I'm only trying positive answers here. So -3, 3, 6, -9, -9, 0. Awesome. And then this can be factored by grouping now. X minus 1. And I see a x times 2x minus 3 plus 3 times 2x minus 3 is going to give me x minus 1 times 2x minus 3 times x plus 3. Huh. Shouldn't get any negative answers, and I do there if I did that right. So I believe that I did something wrong here. Count my sign changes. 1, 2, 3, 4, right? Should be 0. Oh, this is squared. That's what it is. There we go. So we ended up with this option right here. And there we go. So my first one was 1. My second one was 3 halves, are my two positive answers that would work here. Check it out with synthetic division if you would like to there. And we have one more problem for today. Okay. So plus minus complex. Number of sign changes in my original 1, 2, 3, 4. It's going to lead me to there being 0 and 0 there. 2, 0, 2, 0, 0, 4. And I told you this one's probably not an option. There's what my f of a negative x is going to be. Just if you're wondering how I knew it was 0, like that. Factors of 25, 1, 5, and 25. Factors of 4 are 1, 2, and 4. This can be plus or minus 1, plus or minus 5, plus or minus 25, plus or minus 1/2, plus or minus 5 halves, plus or minus 25 halves, plus or minus 1/4, plus or minus 5/4, plus or minus 25 over 4. Let's go ahead and start looking at positive answers here. They're possible. I'm going to start with these integer values before I go on to the fractions. So we have 4, negative 40, 101, negative 10, 25, negative 36. Negative 36 is a 65. 65 minus 10 is 55. 55 plus 25 is 80. That's not going to work. So 1 wasn't my answer. I'm ignoring all my negative answers because there were 0 negatives. Negative 20, negative 100, 1, 5, negative 5, negative 25. There we go. So there's an answer. X minus 5 for x to the 3rd power. minus 20x to the second power plus x minus 5. We're going to get to factor by grouping again. So this is x minus 5 times 4x squared times x minus 5 plus 1 times x minus 5 gives us a x minus 5 quantity squared times a 4x squared plus 1. One of the things that this shows you is that you can have a repeated root. So if I would have used 5 again for synthetic division, it would have worked again. So just because you use it one time does not mean that you're completely done with it. I have x equals 5 with a multiplicity of 2 for my two positive answers. Both of them are x equals to 5. There's two different factors there with that positive answer. All right, that is everything for this video, and we'll come back next time and do some more with polynomials, probably with some complex roots. See you next time.